Welcome, everybody. As always, please feel free to ask any questions along the way. If you're watching after the fact, then please feel free to make a comment and we'll get right back to you if we can. If you think you might like to come on the show yourself, please do get in contact. My details on the channel's About page. Next week, we're talking with Joey Castillo about LCDs, watches, and low power design. But today is Sol Bekic. Hello, Sol.
Hey.
How are you doing?
Oh, I'm good. Thank you.
Good stuff. Do you want to introduce yourself quickly and just say hello to everyone?
Sure. Yeah. Hey, everyone. I'm Sol. I live in Milan at the moment in Italy. And I'm a creative technologist. I think that's the title I've gone with the most. Yeah. Programmer,
Nice.
Developer, something like that.
Sounds good. Cool. So, getting back to your childhood, it's something I like to do at the beginning of the show. You mentioned that you sort of grew up with a parent who was an artist, and they had other friends who were doing interactive pieces with software, electronics, and things. Can you just talk to us a bit about that? How you got sort of interested in it to begin with?
Yeah. So I was always, as far as I remember, interested in engineering broadly, or like technology, I would say, like playing with Lego, what is it called, Technics?
Mm-hmm.
Just like, like the mechanical pieces, Bionicles, these kind of things.
Yeah.
And at some point, through a friend of a parent, I basically got in touch, or I found out about programming, basically, and that it's something that you can do on a computer and you can kind of create things there.
Mm-hmm.
And so I got curious about that, and I started to ask some questions. And eventually I kind of asked, I asked once, like, how to program things, basically. And my example that I came up with was, how do you program a virus? I think there was a conversation going on about that, about like computers going bad or something like that. And I had some kind of impression of what that was. And the first answer that I got was like, oh yeah, you shouldn't really be doing that. You shouldn't be programming viruses. Those are bad. And then my comeback was like, okay, so how do you program an antivirus program then?
I love that. That's
and
awesome.
So I think at that point, my father basically deliberated with that friend a bit, and they came back to me with the programming language Logo.
Okay, yeah.
Which is this little turtle that you can make walk across the surface with commands like forward 20 and then turn left 15, and make loops and do little like spirograph kind of things with that. And I went with that for a little while, with their supervision and guidance, because of course I was must have been maybe 10, something along those lines.
Okay.
But it kind of fizzled out for me. I think I remember a bit of disappointment at that, just because it didn't connect to the idea that I had about programming. What I was imagining, the way that you use a computer normally is not so much about drawing lines, and it's about many other things. And even then, I wasn't using a computer that much, but I was playing Flash games about watering potatoes and things, and that was not that. So so that was I think the very first attempt kind of getting into programming for me.
Mm-hmm. Nice. Okay. Did you get into you mentioned Technics and things? Did you get into Lego Mindstorms and that kind of stuff as well?
Yeah. So
the drag and drop visual ID, where you can actually make effectively Logo but on steroids almost in real world.
Yeah. So that must have been way later, I think.
Okay.
Or way later. A couple of years. Solid couple of years later, I got a Mindstorms NXT kit, and I played with that for a while, for sure. I was using the drag and drop thing, and then I was in high school at the time, or at least towards the end of that time, and there was a robotics club, and they had some resources about, I think it's called NXC or something.
Not quite.
It's like
NQC.
yeah. Oh, NQC, yeah.
I think that was on the so there's the NXT and there's the one before, the RCX, I think it was. That had not quite C, which I remember fondly as well.
Oh yeah, so at the robotics club they had the old ones, the like yellow brick things. And I didn't do much there in that. Like, I visited that robotics club a couple times, but I didn't really do anything. But I found out about, that there was this text language. I didn't really mess with it ever. But I think now, so it's I guess now I would say it's a C tool chain, right, for these Lego devices.
I don't know how C it is. It's called not quite C for a reason. I think it was. Fantastic though. Yeah, good fun.
Yeah. but then I think like at that, like shortly after that, in these like after school clubs, I did get in touch a little bit with like Arduino and
Okay.
making a servo motor turn a little bit or something.
Yeah.
Like basic electronics, and coding on hardware. I think there was a little government funded challenge, like there's like math olympiads and this kind of stuff, and there was something about embedded programming.
Mhm.
And it was about like what I remember is like a 4-digit 7-segment display,
Mhm.
and driving that with a microcontroller, and then I don't know, making an LED blink,
Right.
and just like some challenges like this that you do in a team over the course of a month or two.
Mhm.
I think that was probably like the first time I programmed hardware with this kind of C level approach. Yeah.
Okay. Yeah, very cool. I think when we were talking before, you mentioned that while you were getting into this stuff, there was quite a bit of a struggle with language barrier, and English being the predominant language. How did that affect your ability to get into these things?
So it's hard to say now how much it was my age and how much
Mhm.
it was English as a language that prevented me, like
Okay.
at the beginning, from learning programming. At some point, I know for sure that programming basically improved my English to a level that was really, like, it was in some cases far beyond that of my peers, basically just because I spent a lot of time reading things online in English. And I
Yeah.
was extra lucky and privileged there because my primary school teacher, my head teacher, I think
Mhm.
it's called, she was an American. She was a mother tongue speaker. And in Germany, it's common to start in 3rd grade to learn English
Yeah.
as your second language. Yeah.
I have
And
to admit, I am conscious of how lucky I am to have spoken English my whole life. It's a big step up.
it's and it's definitely, yeah, I mean, it definitely forms people's experience based on where you grew up, and there's
Mm.
many countries around Germany that learn German as a second language, and
Yes.
that's something
Yeah.
that's really, once I realized that was quite interesting and humbling kind of to realize. Yeah, but so I was really lucky that she started grade 1 to teach us English pronunciation.
Mhm.
Basically, I think it was really just pronunciation exercises in the beginning to kind of preemptively stop any of those, th pronunciation problems from really forming. That
Okay.
once you get past a certain age, like learning new phonemes, it's really hard.
Mhm.
Um, and it was really, really great for me. And then once I had like a real application basically for English, I just never looked back, and all my devices are on English everywhere because German translations generally are not that great.
I think I've heard people who work in the UI side of things talking about using the German language because it's
Yes,
always the longest words. It doesn't fit in
yes,
the boxes.
yeah, that's absolutely true. And it leads to funny things when people just have to abbreviate buttons or things like that. Yeah.
Very good. Okay, so you tried Logo, and you had enjoyed that. You got into some other things as well. I think you mentioned Basic,
Hmm.
and can you expand a bit on that for us?
Yeah, so that was way after when other people would have learned Basic.
Right.
Uh, so must have been 2010 or something, at a
Okay.
flea market. I was still interested in programming at the time. I was not actively programming, and it was like before I really got to a point where I was just like self-sufficiently learning and programming.
Hmm.
So I saw this beginner's basic book, like a little thin, almost a brochure
Okay.
about basic programming, in the dumpster. Actually, it was in the dumpster of a flea market. So it was just like people that have spent the season trying to get rid of their old books, and then they put them in
Failed.
there or something. Yeah,
Yeah.
and I just
Okay.
found that and took it home.
Amazing.
And my mom helped me find like a Chipmunks basic emulator or
Nice.
package for the old PowerBook G4
Okay.
that I had.
Yeah.
Um, and then I just went through all of the samples in there, and yeah, there was like little things. I think there was things like, guess my age, lower, higher, like these kind of examples. There was a little bit about like pixel drawing. And where I kind of got stuck was when I tried to build Snake. There was like, I went to the end of the book, and then I kind of went like, okay, now I'm going to build something that was not in the book. And that was my idea, based on the Nokia phones that you would have at the time.
And so was this kind of off your own back? You had the idea to make Snake. It wasn't something from the book that you were being guided through effectively.
I think that I came up with that kind of on my own. Like I was trying to, I think in the end, like there was kind of like an open thing about like, now go out and build the next small game you can think of or something like that.
Yeah.
And where I got stuck was I was trying to save the positions of all of the parts of the snake. So I had to use like an array kind of structure. And I didn't want to settle on a length. I was like, arrays have a size. I was like, how? Yeah. And so I went and I searched like the Unicode infinity symbol and pasted that in. And then I was very disappointed when that didn't work. I had a hunch that it was not going to work. It did not work.
Right.
But then I didn't really recover from that. I wasn't sure how to go on.
Okay.
And nowadays I would realize that there's like, at the worst, first of all, I could just said, okay, whatever, we'll do 16 and we'll see how that goes.
Yeah.
And then, or, like the size of the screen is a limit, but I was not thinking that far, and I was too disappointed at the time. And there was nobody, at least in that moment, that was around and could help me out with that kind of logic problem. Yeah. And so that was one of the dead ends. There was many, I think, quite a few in the journey to get to programming. It's definitely not an easy thing to get through in the beginning.
I think especially when you've got no sort of mentors or guidance of people around you helping, it's real struggle.
Yeah, and that's what pushed me through in the end. Exactly, is like one of our summer vacations. I spent multiple days of that. I don't remember exactly how much, with an uncle of mine that does web design, and he had some old PHP skills that he dusted off that he was not using anymore, but he helped me, or he taught me, making just first the basics, putting some text on a screen, doing some marquee scrolling things, and and then building like a little form, like a input submit button. That was one of the hang-ups I had there. I was also very frustrated with that, and then I finally emailed him after like 3 days. I remembered the submit button of a form. That's like in HTML, it's like an input type submit. And when we did that together, I remembered the word as being submint.
Oh no! Okay.
And so I did that, and it was an input field, exactly. And I went on like there used to be self HTML. It's like a wiki that documented HTML tags, and that used to be in German language as well, and it was a really good resource. And I went there, and I just glossed over that typo basically, because these kind of details are really hard to find when you're not looking actively for an extra letter.
That's one of the frustrations with HTML as well, is that it's so forgiving in that it will try to do what it thinks you want. It won't explode and say there's a problem here. It will, just sort of show something to the user. And so that could potentially have been helpful.
Yeah, for sure. Nice. I think that's one of the good things about Python and this like white space based approach, is like when you see beginners write other languages, you tend to like really be very, very anal about like indentation and things, and sometimes they don't get it, or it's annoying. Like it's really annoying to deal with that, especially when you don't have an IDE that maybe does it for you. But even then, it's kind of a hassle.
Yeah.
And I think like many people don't like Python for that. Like people bike shed over that. But I think that like in the grand scheme of things, it makes it so much more approachable, because there's no way to make something that's like internally inconsistent, where like it looks like it strongly suggests something, but it does the other thing.
Yeah.
Like it just obviates one of those things, and I think it's a big win for learning.
Yeah. No, I agree. The number of times I've helped people with early learners getting on with writing code, and they just present you with this block that's all just left aligned, and it's like, how can you how can you see that? How can you visualize what this is
Yeah.
supposed to be doing? But if you're forced to do the indentation, then as you say, it's the mental model just sort of comes with it. Anyway, good stuff. So you did some web design, started off with PHP, and that was kind of your intro into proper programming in inverted commas. I don't want to say that the others weren't, but
let's say like that was my intro into career programming, basically, you could say, or like professional programming, because I ended up doing a couple of static and websites for like small businesses or just like professionals that needed like a website at the end of high school and beginning of uni, and so that immediately served me well, basically, that skill.
Brilliant. So along the way, at some point, until now, we haven't really done any discussion, or it doesn't sound like you've done any electronics in your sort of childhood. But I think you mentioned you did have a soldering kit at one point, which you put together. And
I did, or maybe it was a couple. I remember a small number of them. Like there was, I think one thing was like a light barrier kind of alarm system.
Oh yeah,
like two little modules that are connected with the cable. They have like an LED and like an IR emitter and an IR receiver, and you can put them like next to a door, and when it opens, it triggers a light because there was nothing else in the circuit. Oh, and then there was like a super loud car horn, not like car horn. It's like a car alarm chip. It's like a little, like it's pretty small, but it was like it was super loud. And we tried it once, and then we decided that was not going to go on the on the alarm circuit.
Jumps out of your skin and put it down.
Yeah, and I think a couple neighbors might too. So it was really I don't know. I was a kid. Maybe it was even more impressive to me, but I think it was pretty annoying.
Yeah. Fair enough. Okay.
And that there was like a bonfire lighting simulating chip, and I think that was like one of the Velleman kit kind of things. It was like a small PCB, some LEDs and passives, and it would like dim and flicker some LEDs,
kind of like a candle type thing. Is that?
Oh yeah.
Okay, nice.
But at that time I learned some basic soldering skills, like all through hole stuff, and with like a non-regulatable soldering iron, and just like very basic soldering. But I didn't learn anything about like reading a schematic or like reasoning about what a circuit was doing on any level. So that I did way later. So there was like this high school electronics programming kind of club where I did like this little bit of Arduino. Then it was much later that I got into that. It was like late uni. Maybe we can jump to that. Like I did my first PCB at some point in uni, and it was actually not an electronics product, to be true. If you want to share the screen, I have it open.
Oh yeah, sure. Okay.
Over here. So I studied game programming, and I don't know, halfway through, something like that, I joined a group of friends that started an indie game studio and developed this game called Bekic.
Okay.
And so for one of our showcases at Gamescom, I knew I had found out about BoldPort.
Yep.
Which are these really amazing artistic PCB kits.
Yep. Fantastic.
Yeah, really great. I subscribed a while at the end of before they stopped making them, but I really enjoyed those. Can highly recommend if you can find one to pick it up. And I saw that, and so I thought I would try my hand at that, and I designed these little keychains basically.
Brilliant.
And played a bit with the different layers. So if anyone's not familiar, basically the different colors here are made up with all of the parts of a regular circuit board. So on these are all silk screen. Okay, there's another version where the white part is actually exposed copper, or rather, what is that? It's like some kind of metal that gets put on the top. But for example, like this yellow and this yellow, the difference is that underneath here there's metal, and then this is just the solder mask on the raw PCB. So I learned a lot about like the different parts of a PCB and all of the tooling, because I made these in in a mixture of KiCad and Inkscape, I think.
Okay.
Yeah.
And so this was your first PCB, is that right? You just said that just now.
I think it's my second. I think before that I did one thing and it didn't work. I just went from schematic to PCB without doing a breadboard anything.
Right.
And I spent weeks reading what is it, like a PIC 16F something, like a little PIC microcontroller data sheet, and tried to figure out how I was going to program it and everything. And then I just had too many problems in bring up to go
too
through
many
with
unknowns.
it.
Yeah. Okay.
Yeah.
Very frustrating.
Yes. Yeah. I mean, it was frustrating. And then I think this was a good rebound project, kind of to put all of that, learning investment of the tooling to
absolutely.
use. Yeah.
So you, as you say, you've got here the white is the silk screen, the sort of the orange yellow color, or the red is copper with solder mask on top, and then the rest is just solder mask on a PCB. How did you go about translating a design, or is this a fresh design that you made? How did you bring that to the limited colors effectively that you've got here?
No, I made that to measure, basically. I mean, the design elements, so like the you could say like the brand identity of the game, like the V, like that's an existing vector design, and also the writing here. And the thing about these circles, these are all elements of the regular design, but it's usually more colorful.
Okay, I see.
Let me see. There's not a great example here, but in the background of this, you can see like it's all about like very rainbowy in your face colors.
Yep.
So I just try to boil it down to the contrast that you need kind of here.
Yeah, that's brilliant. Looks really good. Well done.
Yeah, thanks. I actually I still have one of these on my keychain. I wish I had it here. I didn't think about that because there was this. I made more. So there was red and yellow, and then there was another red and yellow with like exposed metal, and that's I think the more interesting one in the end. So that the one that's more PCB like, because you actually see the shiny surfaces that you want to see there. Yeah.
Very cool. Nice. Well done. I'll take that away. There you go. So you mentioned then obviously during uni you were doing game programming. Was that your course, or do you want to reintroduce that?
Yeah. So it's a study program that's called Digital Games.
Okay.
In Cologne at the TH, the Cologne University of Applied Sciences in English. And the program is in English, and it pulls in quite a lot of international people. And so the classes are in English. Most of the people I worked with were talking in English, and it was nice. The program basically works on 3 tracks. So you can, when you apply, it has like a rather limited number of seats, so you have to do like an application process, and you basically have to pick one of the 3 tracks in advance, and then you have 1 year before that choice becomes effective, and you can still change in that time. Afterwards, it's a lot more, like it's still possible, but it's more difficult. And so there's programming, which I did. There is arts, which is anything from 2D concept art, for example, texturing, 3D modeling, all of that. And then there's design, which is not arts, but it's just like the game design part. So it's about coming up with mechanics, as well as narratives, all of that. And for the first year, everybody goes to all classes, basically, which is, I think it's great. It's like in any case, if you're going to be working together in teams, you want to have some kind of foundational knowledge of what the other people are going to be all about, basically.
Definitely,
and then every semester there's one group project.
Okay.
So it was definitely also good practice for like something that you really have to learn the hard way is scope. And so every single semester that comes back to haunt every single team.
Overpromise and under-deliver sort of thing. Is that what you're referring to?
Yeah, like it's just about picking a project that is actually doable in like the 1.5 months that you have. You always overestimate your abilities in like the amount of things that you can do, and you always underestimate at least one of the big challenges of the project.
Especially when you're young and ambitious at uni.
Yeah, for sure.
Okay, Nice. So I think while you're at uni, you then got involved in the Fab Academy. Is that after uni or
Oh
during
no, that
uni?
was after. So that
Okay,
was
apologies. Yeah.
immediately after. So I
Right.
finished or immediately. Yeah, no, yeah. I didn't go in the quickest amount possible through the course. I did get a bit sidetracked, and I
Hmm.
think I extended it by 2 semesters in all, because I started working part-time halfway throughout, and then Unity became relatively unimportant at times, and back and forth. So I ended up taking some breaks,
Okay.
and then I moved to Milan with my partner, where we live now.
Hmm.
Um, and actually, the reason we moved here, or like one of the reasons, it was the Fab Academy program. So
Aha.
we were both wrapping up our studies, my bachelor's and her master's, at the same time, and we were feeling like going elsewhere, leaving Cologne, and we were not quite sure where. I had some family in Berlin, and we were considering that. We both liked the city, and she's Italian, but she's not from Milan, and she
Hmm.
was also contemplating trying out Italy again, basically, because
Right.
she grew up there. She studied also in the north of Italy, but she hadn't lived adult life
Hmm.
in Italy, and she was curious in a way. Um, but it was, in the end, it really came down to me and the Fab Academy thing to put that as a concrete out there as a concrete idea, because so the Fab Academy, it's a course about fabrication, about like 3D printing, laser cutting, CNC machining, that is run in a decentralized way.
Okay.
So there is a part that is online lectures,
Hmm.
um, on Zoom, like just like Skype, whatever, online conferencing. And then the other part is like in-person, on hands-on work with the machines, supported by a local Fab Lab and a local instructor,
Right.
importantly, that can guide you through all of the things, that knows all of the gotchas of the actual machines that are there, that can point you to the right materials, and then individually supervise you as well.
Hmm.
Um, but that means that you can only do it where there is a Fab Lab and a willing instructor, and a
Yes.
group
Yeah.
of, at least, I think it's usually 3 people that sign up for it in a specific location, because otherwise, the instructor is just not going to be able to put in the time supervising a single person somewhere.
Sure. Sure.
So I had seen something on Twitter about the Fab Academy, I think like a year before, and I like browsed the website. It seemed pretty interesting. I think the cycle had just, like, the application phase had just closed, and also I was in the middle of my studies, so like, okay, that's
Hmm.
interesting, but
Not
can't
for now.
really do anything with that right now. Yeah.
Yeah.
And then that kind of came back around, and I looked into it, and like, first, like, it was really, like, it was literally a joke about, like, oh yeah, maybe we'll go to Italy or something. And then I checked the list, and it was like, oh, there's actually no node in Berlin that is available. So there is, or was, the Berlin Fab Lab,
Okay.
but they moved, and then I think they never reopened still.
Right.
Maybe that has changed in the meantime. But there was some kind of logistical space, anything issues there. And so it turns out that actually Berlin was unexpectedly not a place where you can do that.
Hmm.
And then we were like, okay, let's check the list. And there was Milan on there. And yeah,
Everything
my
started to
partner,
fall into place.
yeah,
Yeah.
she has some remote family here. So we went here, we came here for a weekend just to, see the city. She knew it.
Yeah.
I didn't. Um, and things fell into place. And yeah, in the end, I ended up doing it here.
Awesome. So tell us more about that. What got you into it, I guess, and what you actually
Yeah.
did on the course? Because until now
So,
you've done primarily software. Game development is
yeah.
typically very soft and on the computer. So
Yeah.
this is quite a dramatic change, I guess.
Yeah, so in game programming, there is one semester in our course that is experimental games. That's
Hmm.
the topic of the group project,
Right.
and for that project, I got in touch with one like Juan Orjuela of the Ludopium team. So that's the game, the indie studio of the keychain thing.
Okay.
So that's a music game, and he's the musician of the team.
Right.
Um, and we became friends around this time. And he was 1 year above me, and it was actually his experimental games semester. And he was starting to form a team, or they were starting to form a team around electronics. And I had some, basic knowledge about that. I was kind of curious. We got talking about it, and we ended up making a semi-interactive music performance experience as a semester project.
And so this was a physical, out in the world kind of thing, rather than on a computer.
It was on a stage. Yeah. So it was
amazing.
4 of us. We had, 5 of us.
Okay.
And we built we did a little bit of circuit bending. I tried to do some strip board soldering. We did a couple of things that worked. A lot of things did not work the way I thought. It was we made music and had it was based around flea market toys, a lot of it,
right?
And that tied it kind of into the game thing very loosely, I have to admit.
So was that really extracurricular outside of uni, or was that something
that was a semester project? It was a semester project. They gave us the green light.
I'm delighted they took that on. Yeah, that's fantastic.
Yeah, it was a bit of a gamble from our side pitching that, and we were very happy that they did take it.
Yeah.
And I think they enjoyed it mostly as a way to just get out of the box. I think they appreciated it in a way. It was definitely not very gradable, I think, in the sense that other projects were. I enjoyed it a lot. It was really great, and it definitely pushed me in this direction of the track that I'm on, you could say.
Oh, fantastic.
Yeah, so exactly. So here I got into hardware again in a way, and messing with things, making things. I learned a lot from my colleagues in that project about pragmaticism and just getting things done, and just taking a Dremel to something and making a hole for when you need a jack,
to be
and
there,
things like that.
Put it there.
Yeah, and it was really great. And so that, I think, really fed into the idea of going to the Fab Academy. So the Fab Academy, it's a private paid course. It does not cost a very small amount of money, at least for me anyway at the time, and for many other people, I'm sure. They offer some stipends.
Stipend.
So it's not necessarily if that sounds like an issue to you, you should maybe look into that. It's definitely possible to get by anyway. And for me, basically, the thought process was I had finished the bachelor. I was already working in software development, and I could have gone full-time into that, kept going part-time if I wanted to. But I kind of wanted to do more of this hardware, experimental, whatever thing. And I had been teaching myself electronics in this side project manner on the side a little bit. I had played a little bit with 3D printers on the side. At one point, I wanted to laser cut something, but I didn't get to the point of actually doing it. Right. And so I figured that this was going to be a way for me to have a space to do that, like in the sense of like time and space, like space in my life to dedicate to experimenting with these things.
Yep.
And it worked out really well for me. So because basically, so the course is 1 semester, and every week there's a new topic. And every week you do like a mini project based on a topic. So it starts out with programming, with web programming, because the whole way through the course you are supposed to have like a blog where you publish your weekly results. Yeah. So week 1 is setting that up. And then week 2, I believe, is cutting. So that's laser cutting and vinyl cutting. Then I think next is 3D printing. Then there's like 3D modeling. It's like a secondary step. And then you go for CNC machining and other things. And it's really, really dense. Like 1 week per topic is very little time.
It's quite fast.
Yeah, I was, again, very lucky here because I had programming experience before. And that's something that definitely tripped up many people that went into it. because so basically you are graded partially or like to a large part based on your documentation,
Right.
and that's all in HTML form that you have to present to people around the world essentially.
Yeah.
And that's all in the Git repo. That is that is, I mean, that's a bit of a, I don't know what I think about that, but it's like a write protected main branch. So
Right.
if you put in, like, they warn you very explicitly and repeatedly about this, but if you upload a 100 MB JPEG to your main branch day one, then you're going to have to beg an admin to unlock your repo and start over, or you're not going to have space anymore for pictures later and
Oh
things like that.
no.
So
Okay. So
yeah,
there's a
it's
lot
like,
of potential gotchas and a lot of stuff to know, like day one, in terms of writing HTML, dealing with Git, dealing
I mean,
with images.
so the way it works is that, so first up, there's warnings about these things,
Right.
at least, you know, and they explain how to compress images, how Git works, blah blah.
Okay.
They try anyway,
Yeah.
but there's definitely a lot to catch up on there if you haven't had any experience with that. And especially, I think the main downside is that not everybody who would enjoy a lot of the other parts of the Fab Academy is going to be very interested in programming per se.
Absolutely.
And you know, making that one of kind of the cornerstones of it in that way, I think, is a bit questionable.
Okay.
So one way that they try to kind of help out there is that there's like extra classes in some of the weeks, including this first week, that is kind of like it's like an extended Git and web lesson, basically.
Right. Yeah.
And
Okay.
they have like a template repo with MK docs set up so that you just like, they show you the basics of Markdown and the skeleton is there, and you plug in a couple of things. Like, that's the idea.
Yeah.
And they have like, they take extra time to bring everybody up to speed who wants to, you know, do like the bare minimum to get by there, and who's starting from scratch.
Yeah. Interesting. Okay.
Yeah. And yeah, so that it was supposed to last 6 months, but COVID hit like a month in.
Right. Okay.
And so that year was extended to like a full year. And I did it all of that year, for sure.
Got your money's worth.
Yeah.
Well done. Yeah. Nice. Okay. So that was kind of like, you know, outside of uni, after uni, it was an extra lump of learning effectively. And that really equipped you, by the sounds of it, with a lot of skills.
Yeah. So I really enjoyed every day of that. It was really, really valuable to me because I knew beforehand, like, I had proven to myself that I can learn things on my own effectively to a degree. I had learned most of my programming experience, like, that I apply in you know, my professional work, online, just Googling things and reading a lot of articles and playing around with side projects. And that was fine, and it was easier to do for sure when I was in high school and in uni. And as I started working more on the side, that definitely became, you know, less of a possibility. And then tackling these new topics that are like completely new, it was definitely much harder, or at least much more daunting, and like harder to dedicate time to. Like, it's much harder to be sitting at your desk and be like, okay, I'm going to look up where I can go and learn about laser cutting today, where I have zero experience. I don't know if there's anybody who will let me do it.
Opportunity.
And
Absolutely.
and I don't have a reason, actually, tangibly, like a reason. I mean, I want to learn it. That's a great reason to do it, actually. But there's not a reason that I can tell other people of, like, yeah, I need this for whatever.
I think having a project in mind is a big one, and as you say, you know, having the opportunity to actually do these things is a massive blocker. You know, there's a lot of resistance to learning something if you're never actually going to be able to do it, which I think is fair.
Yeah, and so that was really the reason I chose the Fab Academy, was that, like, I knew that, yes, theoretically I could learn these things, but I knew it was never going to happen if I didn't seek out some kind of context or framework or whatever, where I had the chance and the, you know, the time and everything and the resources to do that. So that was my motivation, you know, for going to the Fab Academy, and it's pretty much how it went. Like, I'm really happy.
Brilliant.
So I basically had like this year of access to a lab, including a reasonable amount of materials, basically.
And very jealous. So Oh, sorry. I was just going to say, since
No.
then, what have you been up to? I think
Yeah,
you're
so
currently
since then,
carry on.
I think it's time to switch the camera then.
Oh, okay. Yeah, sure.
Maybe. So let's see. Here we go. That's the desk cam.
There we go.
So yeah, so the Fab Academy ended with the final project, which took up. The idea is kind of that if you have an idea in mind from the get-go, then all of your weekly projects are kind of leading up to this. So like you could be 3D printing a part of this in the third week and then making the PCB in the fifth and so on.
I see.
But if you don't, then you're going to end up doing a lot more work later. And it
sure.
was mostly that way for me. So what this is a keyboard. It's missing the keys, actually. I had to recycle them at some point. But up here, there would be hexagonal white keys, sort of like this. And so it's a keyboard that you can use like this in like unibody mode, you could say, to play music on. Or you can separate it into two halves and align the fingers a bit differently and type on it.
Interesting. Okay.
And it has like some magnetic snapping thing here.
Yeah, nice.
It was supposed to connect with these like little pogo pins here, but that didn't end up working.
Okay.
And it can also snap together like this in like travel mode.
Yeah, nice. Okay.
And so that was my final project, and that took a long time. Yeah. And it was really, really rewarding. Really, really rewarding to put all of the skills together. Because so on this, there's a lot of stuff. Like there's very little actually that I didn't basically do. And that's like the whole point of the final project. Like that, it's a requirement actually to do things this way, basically.
Right.
So these PCBs, for example, have this weird dark shine to them because there's no solder mask.
Okay.
And this is a double-sided PCB that was milled from like a blank piece.
Fantastic.
In a CNC machine.
Yeah.
I think it's going to be hard to focus on the details here, but
don't worry. Yeah.
Yeah. So you get the idea basically. And this whole plastic body was also machined out of plastic. And the keys. So these are some earlier keys that I made for this project, and they are these are made of epoxy resin.
Okay.
And so for this, I machined a wax mold and then cast the epoxy into that. And that ended up, for one, being very cool because they get this little, like they're nice and translucent. They have this blue sheen to them, which is actually the color of the wax mold, kind of,
amazing.
I don't know, seeping into the resin or something like that. And some of them, I'm not sure here, I don't have great examples. They have little bubbles, which you can see as a defect or just as a really nice look.
Yeah.
That was interesting, but it was a little too hard to do reliably. So the next stage were these kind of hard to focus on these things, like these kind of keys that have been milled directly from plastic. Or machined out of plastic. Yeah.
Interesting. So there's a lot of I imagine that's not a one-step machining operation. So you've got to deal with work holding and locating and things as well as part of this design.
Yeah.
Very cool.
There was definitely issues. So the one thing that happened with this frame case thing, that was a gotcha that threw me and my instructor for a loop for a week and 3 revisions.
Oh no.
Basically, when you're milling the top and the bottom, you're going to have to flip it at some point. And so I had a fixture that I milled out of wood that had like the negative shape roughly of the top half. I would start with the top half and finish that, and then flip it and mill some pockets and then do the outline.
Right.
And what would happen is that here on the top, there's like a little chamfer. And once it was done, that chamfer was not going to line up on the edge of the outline. It was done from the back. And all of the keys, basically the front and the back, they were offset. And, I thought, okay, that's weird. Did I mess up the coordinate origins or something like that? So I did it again, and that was the same result. And I was really careful about checking all of these things. And it turned out in the end, what really happened is when you have a hexagonal grid like this, it's not so having the negative of this profile here all the way around, even up to here. You look at this and you're like, with like somebody who went through math class, you're like, okay, that's like X is constrained. It can't go left any further. It can't go right any further.
Yep.
Or I mean, it could go right further, but I have something else pushing, or like I push it that way or something.
Okay.
But like oh no, yeah, like no, I look up here and I see that up here it can move left or right, right? Because like if there's like a triangle sticking in here, it's like it's locked that way. And
Sure.
it can't move up and down, right? Because the same thing is going on here.
Yeah.
Well, it can slide this direction.
Diagonally.
So,
yeah.
Yes. And so I would push this into the fixture, and it was kind of a tight fit. And so I would be like, okay, that's in there, good. And I would screw it down and start machining. But I never pushed it all the way to its limit in that direction, because I assumed that there was just one position. And so all of the fix was just taking a little piece of wood and like hammering it, like tapping it into position this way, and then screwing it down. And that ended up being the fix.
Oh, how frustrating, but well done.
Yeah, that was soul crushing for a while, because I looked at it for a long time. My instructor looked at it and had no idea what could have been wrong. But at the same time, obviously, they hadn't watched me do every step of these like day-long machining processes. And so they couldn't really give me any advice either, until I think I just did it again. And I think in the end, all I did was just, I had it in there and I was just wiggling on it and be like, what is wrong? And I figured out that actually it does slide. Yeah.
Oh dear. Well, either way, that looks really, really good. Well done. That's a great final project.
Yeah, it actually, something happened and it doesn't work anymore, which is, these PCBs are fragile when they're done this way.
Fully exposed and
all of the vias are little rivets. That go through, I soldered them on the top side. That's all of these little dots everywhere, because otherwise they are completely unreliable. And I'm assuming that one of those just doesn't work anymore.
That's a shame.
Yeah, I mean, it's okay. Actually, the thing is that the halves individually still work. I don't know if I'll ever get around to changing the PCB, maybe, but I made a good video of this project, luckily, because that's another requirement of the Fab Academy.
Okay.
And it's also a good thing, like this habit of documenting. I'm definitely not doing it as well anymore as I did for the Fab Academy, but it's really nice having good documentation of this project now. I'm really happy in retrospect having that. And I don't have the same level of documentation for other projects, and it's definitely something that I'm trying to do as consistently as possible.
I think that's a very good point. I've certainly found that you look back at projects and you go, oh, I didn't take pictures or whatever it might have been, and
absolutely.
No, good point. Okay, so you finished the course at the Fab Academy, and you're now actually involved in a slightly different capacity with the Fab Lab. Is that right?
Yes, I will switch back to the face cam. So it's not the same Fab Lab; it's a different one.
Okay.
So the one where I did the course is Open.lab in Milan, and that one is run by a design studio that has acquired these machines for prototyping, and they opened the lab up to the public as a Fab Lab, as a makerspace. And now I am working at the Fab Lab Unitn, Uni Trento. So it's the University Fab Lab of the University of Trento in the north of Italy.
Okay.
And that lab has been open for just about a year now. So it's pretty new. And I was lucky enough to be made aware of the position, basically, as they were starting out. And I've been working there to a degree, maintaining the machines and documenting some of their quirks and figuring things out, and helping students get access to these machines, basically, and have the basic skills to use 3D printers and laser cutters for the main part.
Okay.
We also have a digital sewing or embroidery machine.
Okay, nice.
Which is interesting. And we have some CNC mills, but that is a much bigger step. Like it takes quite a bit more, learning basically to get confident with that, I would say.
So is that something that you are skilled up on, but it takes a lot longer for the students to get on, or is that something that you're still working towards getting comfortable with yourself?
Both. I mean,
okay.
I'm definitely confident to a degree with it. Like in the Fab Academy, I did. So like the keyboard that I show, the case is a 3D milled part, and the keys are as well, the key molds. So I did learn a lot about that, but it's still. I'm starting to learn about machining metals. Because we have like a open metal mill at the Fab Lab.
Right.
But that there's a huge amount of things to learn there that I'm excited about learning. And for students, we try to start with like 2.5D milling, you could say.
Right.
But it's also, I think, one big factor is just it's a much more opaque kind of technology. Like it's not something that people are aware of coming into the lab, that it exists usually.
Yeah, that's interesting.
Like people have, everybody who walks in knows about 3D printers.
Yes.
And then most of people, either they know what a laser cutter is, or they can just see it and grasp it.
Yes, yeah, it's like scissors, but
in seconds.
Yeah,
I mean, and you can show the parts, and it's very quickly, it's obvious to people like what you can and can't do with that.
Yeah.
I mean, you can do some pretty interesting things with assembling pieces and getting like, you can go wild with that, and then like living hinge things and I don't know, flexures. Like there's definitely like a long tail of things you can do there, but like the 95% of what people do with laser cutters is something that you can just grasp seeing it immediately.
Yeah.
And then like a milling machine, the limits are like really fuzzy, I think. When you get started at the very least. So and then it's daunting to get into. Like it's different when somebody wants to do laser cutting and I can show them Inkscape and it's just like, hey, like draw something and then we'll cut it. Or when you're milling something, if you want to mill something, then either I have to do a lot of like magic wand waving and put in the feeds and speeds and things like that, and choose the right tool and all of these things. There's a lot of front heavy, I think, learning to do there, kind of.
Yeah, sure.
I think for my first milling operation, like first 3D milling thing, I did setup for a week for sure. I think I definitely spent a week in the CAM module of Fusion before I did like the first operation on that project. And I had already done 2D milling with a different software flow before that to make some basic PCBs. And I had like a 1.5 hour lecture about milling, and then another one about mold making, and like there's a lot to take in there for sure.
Yeah, absolutely. I love your point about the ability to grasp it and I guess the public's knowledge of these tools as well. That's a really interesting point. Yeah.
And it's funny because I still am blown away a lot of times when I figure out about what actual industry machines are like and work like, and what the kind of things that they can do. Because all of my experience is from the 2 Fab Labs essentially, and then watching all of the Blondie Hacks videos that you can find online, basically, which are really good. I highly recommend that if anybody wants to get into machining, metal machining. She does a really, really good job of explaining all the basics of that.
Good stuff.
And yeah, so like seeing like an industrial grade 5-axis metal CNC machine, it's a completely different beast. And I have no clue how the actual operation feels like the software tools and the hardware controls. I'm sure that there's some resemblance, the same way that the smaller and the bigger laser cutter that we have in the Fab Lab, they share the same principles of operation. But looking at those control panels and things, I'm sure that there's quite a lot going on there that I have no clue about.
Oh, one day you'll get that.
One day, maybe. We'll see.
Brilliant. Cool. So if we come back to your keycaps and things, I think,
yes, sure.
particularly sort of your keyboard in full and prototyping. This is, I think, a really exciting project. You'll talk a bit more about it, and I'll sort of poke you as we go.
Jump
Yeah.
back to this camera.
Yeah, sure.
So I showed this this is basically like the original project, the prototype 0, you could say, maybe,
Yeah.
of this like musical hexagon keyboard idea, which is not my idea, to have a musical keyboard based on hexagonal keys and this kind of grid, like this one. This is actually, I guess, like 18th century tech, you could say.
Wow. Okay. I didn't expect you to say that.
Yeah. No, and it didn't. It's just, one of these
Actually,
alternate timelines.
What's it called? A squeeze box. What's a squeeze box
Oh
called?
yeah. The
Accordion.
like,
Is this
accordion.
the same kind of layout as an accordion?
Well, yeah, the layout is the same. So like the grid is the same.
Yeah.
But the accordion, as far as I know, and I could be wrong, there's also like subtle differences there. Like there's a couple instruments that look similar and that are very different, I think. But the one that I know about so far, each key is a chord.
Oh, interesting. Okay.
So you press one key and that makes multiple separate tones. And this is a musical keyboard in the same way that like a piano works. And so each key is one note.
Very interesting.
But the grid is the same. Let's get to demonstratability here. Yeah. So here, one sec.
Sure.
Put a microphone there. Okay. So this is connected to the iPad right now, and this is just like some random synthesizer app. Okay. So this is a MIDI keyboard, and MIDI is like this 90s standard for sending notes between music instruments. And it has like a USB incarnation. And so if I press keys here, maybe I'll turn it up a bit. Let me know if the volume is...
Sure.
Is that better?
Yeah, that sounds great.
Yeah, so exactly. So these are now just keys. Each one corresponds to one of the regular notes on like a normal keyboard layout.
Okay.
And so in like, a couple hundred years ago, there was rivaling layouts, and the one that won is one that I personally don't enjoy very much. The learning about, that's the main point. The reason I wanted to do this is because I have no musical training and I don't play an instrument, but I've always been somewhat curious. And in researching these things, I found out that one of the things I always found very confusing in music class in high school is completely unnecessary. And that's, so the way that like the black and white keys are arranged is made for C major. So if I play all of these notes down here, that's a C major scale. And let me see if I can, that's a C here. And so on this keyboard, that is not a straight line. That is actually these colored keys here.
Okay. Interesting. Like okay.
And so the thing is that if you want to play a C major scale, then that's that shape. And if I want to play instead a D major scale, so starting one note in, basically, I can set this keyboard up to start there.
Right.
And don't know if you caught that, but it's the same shape. It's just moved over one bit. Oh. And if you want to do that here, then instead of now press, like for C major, I just pressed all the button keys.
Yeah.
And now for D major, it's just like a jumbled up complete mess all over the keyboard.
Just start picking some random black ones too.
Yeah. Okay. And that's something that this tripped me up at some point in high school for sure. I didn't get over this logic.
Interesting. So if I presume the mapping for the keys underneath your lights hasn't changed, is that right?
Yeah, it's the same.
So those four that are on the right-hand edge of that lit up block.
Yep.
In the center block. The four that have just lit up because we've shifted the block over.
Oh, these ones. Yeah. I see what you mean. Okay.
Those are the black keys, are they?
Yes.
Maybe.
So when you are in C major here, everything that is now not lit up would be a black key on the piano keyboard.
Correct. Okay.
And so now if I move over, then you're right. These are the four new black keys that I have to start pressing if I want to play the scale. Yeah. And here there's four keys that used to be white on a piano keyboard that I'm not using anymore. Yeah.
That's fantastic. Okay, cool. So can you play us a song?
I can't do that. No.
No, no worries.
I've gone too far into the engineering part of this for sure, and I've not spent nearly enough time doing any of the learning.
Okay, that's fair enough.
But hopefully I'll get there. I did realize, I think I realized this like a month ago, that I hadn't even started doing any kind of piano learning.
Oh.
And so I hopefully will find some time for that.
Mm-hmm.
Definitely
Nice.
should be getting back to that. Yeah.
Yeah, no, very cool. So the the keyboard here is a musical instrument basically, or at least the input for one. And I have to admit, when I first saw your keyboards, I presumed they were for typing on with words and letters and things. Is that just something that's completely incorrect, and these aren't for typing at all?
No. So the first one was both. That was the intention.
You mentioned
with this
you
one,
could have it in two halves.
This exactly. And definitely, so I've been posting these things online, and I've gotten in touch with Simon from FK Caps, which is a company that makes keycaps for regular keyboards, for this like mechanical keyboard. Like this is an unfinished keyboard from that. People get very intense about making their own keyboards. And there's like millions of different keycaps that you can buy, and FK Caps makes these keycaps, makes some of these keycaps, and we got in touch at some point when I was starting to do all of this, and they were interested in making these keycaps a product, basically. Because up until that point, we're using the machined and epoxy molded keys. It took me a whole day to make, I think, 40 keys for the old prototype, and they came out at different heights and things, and I had to do hours of cleanup, like picking out little fuzzy pieces of plastic from the bottom, burrs and things like that. So there was no way I was going to be able to make that accessible to others that were interested to have something like that. And so I got into touch with Simon, and we ended up doing this collaboration. It has been going on. I mean, it's been taking a long time. It's over 2 years now, I think. But we finally have injection molded keys. So the ones that are on these two keyboards are actually, this is like the first test run from the factory. And I won't be able to show this on camera, but there's like some very minor defects. Basically, the ejection pins, maybe the bottom one I can show maybe. So you can vaguely see some circles there in the light in the four corners. And this is where there's basically like metal pins coming out and pushing the keycap out of the mold when it's made. And that leaves like an indentation there. And on these ones, since there's like light shining through the back, these need to be rather minimal. You can see them. And so the factory just was not made aware of the fact that, that's relevant for these keys. And so in the second revision, basically, I think they just were a lot more careful about how exact those pins are. And so now the circles are still in the same positions, but they're so minor, even on the backside, that you don't see them anymore. Basically.
Oh, brilliant.
So that was one revision that we had to do. And then there was some small details about the surface finish on the top. But these are the second prototype run, and they're actually in production right now.
Amazing. Well done.
Yeah, that was a really, really interesting process.
Yeah. So how involved were you in getting them, the injection molded tooling and whatever else up and running?
So that was taken care of by the injection molding factory for like almost all of the process. Basically, I provided them with the model that I had validated in my own machining experiments. Then I still made some tweaks after that. But the model was kind of proven at that point, at least from like the usability aspect, you could say, like the overall shape and the size of the bowl on the top and all of these things. And actually, one thing that I was very anxious about in my own work was the fit of how they fit onto the key. There's like a friction fit where like they're pushed into two little holes. So like a key underneath, it looks like this. It's like two little holes there. when you push it in, and it needs to be the right amount of friction for it to like stay there,
not pop
snugly,
out, or,
but you can still pull it off and replace it
Yep.
without damaging either of the parts. And so I managed to tune that to a degree. It was never perfect in my own production. And then I had some 3D printed from a professional 3D printing service. And they just came out a bit too loose because I just had no idea how to figure out like the exact measurement to give them to give me back to have the right fit.
Sure.
And I was pretty worried about if I was ever going to do injection molding with this, which I also was completely, I was not feeling like I could do that on my own and figure out all of the communication, the testing, the amount of money that you need to be able to do that.
It's much
and
more,
I was just scared, like, how many iterations would you need, to get that fit right, and how does that work? Are you going to have to pay each mold revision, and all of these things? So it turns out that since this company that I was working with makes keycaps, they actually have an existing design.
They've been through that before.
Works perfectly, and
brilliant.
so they just put that design on the bottom of my top design, basically, and the fit came out perfect first try.
Amazing.
So that was it was really good to get a lot of that stress off my mind.
Yeah.
I had enough of that just dealing with the rest, because so basically they were in charge of keycaps, and so for this macro pad that we're about to sell, there's two other main components, and that's like the aluminum parts of the case, and the PCB.
Okay.
And so this is the first time this one is hand soldered, but these boards in general are the first time I did PCB assembly, like SMT assembly as a service. That I used that. So that was nerve-wracking for sure, ordering 400 boards and having them assembled and flashed.
Yeah. Okay.
And
it's all gone okay, has it?
Yeah, it did.
Brilliant.
So that was also, I couldn't find much resources about that, about like how does it work when you tell somebody to make these keyboards and these boards and flash them with firmware, and then like what if some of the LEDs don't work? And I gave them a test guide for the LEDs, and like are they just going to send me the broken boards with like a label of broken and like deal with it, or what is like the percentage of LED failures where I can say, hey, like 50%, maybe that's not right. Like 10%, okay, maybe I can fix those manually, but if half of them come back broken, like I had no idea, and I tried to find that with no success.
Okay.
And I think I really should. I'm going to try to do like a write-up of that, because there was a lot of questions that I had that I couldn't find answers to online. It turns out the company that I worked with was pretty nice in that regard. So I don't even know how many were broken. Right. There was some broken ones, and I gave them the testing procedure. There was a nerve-wracking 3 or 4 days of back and forth while I figured out how to provide them with a batch file to program the boards, because I didn't have a prototype on me, on vacation at the time, and I had only ever flashed it on Linux. So yeah. And so I couldn't know if there was like a hardware issue or just like the wrong flags or whatever, and it ended up working perfectly. It was just stressful days, and then they just fixed the ones that were broken, and they didn't even charge for that. So
nice.
They might have put a bit of extra time in like the testing fee, because that's billed hourly, but I was positively surprised by the experience. And yeah, definitely something that you're gonna have to get used to if you're gonna build more on the regular. And I mean, it's kind of the same feeling as when you start ordering PCBs. Like there's a very significant amount of anxiety to get over to hit that order button.
There's a lot of new stuff, unknown questions unknown answers to questions you haven't asked yet, and all this kind of thing, which a lot of it seems to just come with experience, doesn't it? You run through the process more and more, and you get more and more comfortable with it. But certainly at the beginning, it's very daunting. I'll give you that.
No, and also just like this, like letting go of a version of something and sending it out, like that's coming from software. You would have to compare it, I guess, to like releasing like a version of like production software or something. but it just doesn't feel anywhere close to the same. And it's just like at the scale of what I'm doing, like this DIY stuff, like you're ordering like 5 boards from somewhere, and the biggest cost is the shipping. But you're gonna wait a couple of weeks for that. You don't want to waste that time, money. You don't want to have to spend the time of trying to bring up and figure out it's not gonna work. All that, like it's a really big hurdle to get over.
Yeah. Fantastic. So are these macro pads, you said you're going to be selling them soon? Is there somewhere people can go to buy them?
So the best thing right now to do if you are interested in one of those is to go to my website and find the link for like an old form that we have. Basically, these are going to be showing up in stores of existing keyboard part sellers.
Oh, nice. Okay.
So we have, I'm not going to name them because I'm not 100% sure which of them have like finally confirmed that. But
no worries.
There's going to be one EU-based and one US-based shop for sure, as far as I'm aware, that are going to have these as a kit. So it's always going to be, there's going to be some soldering required, and it's just through hole. Like you solder in the switches. And the reason for that is that like with many mechanical keyboards, like there's different types of switches you can put in and have like more clickiness or less, or more or less resistance. And so you can pick your own and solder those in, and then screw in 4 screws, and that's it.
Okay. And how was it getting your product into shops, basically, to storefronts?
So I was again very lucky in this collaboration that I managed to find because
they had a lot of ways in for you already.
FK Caps has been selling keycaps for a while. Not for very long actually, but longer than I have been designing keyboards for sure. And so they have contacts, they have ongoing relationships basically with stores that sell their keycaps.
Right.
And so we originally were going to do this in like a crowdfundy fashion, which is very popular in the mechanical keyboard scene in a very informal way. It's not like Kickstarter or crowd supply or anything. It's just like somebody posts, hey, I'm going to make sets of these keycaps in these colors. Who wants them?
Right.
And then people send them money or sign up for emails or something. And then they do it. And then lately, it seems these things have been arriving like 2 years after the fact. Like the times of delivery have been rising dramatically because there's just a couple of known companies that make keycaps on demand.
Right.
And they have just been saturated. And people keep making new sets. And so there has been like a growing grudge kind of in the community against, just like, it just doesn't feel nice, this process. And also on my side, I was very nervous about it, about like, taking people's money and the responsibility that you have, obviously, at that point, as well as legal liabilities. And what if I mess up the PCB assembly and I have to redo all of the boards, and the cost of that is not going to be planned? I can't have a margin that big planned in ahead of time.
Absolutely.
What do we do if all of these questions? And the whole project took 2.5 years. We would have for sure broken a lot of deadlines that we would have announced. So I am very happy that what ended up happening was that FK Caps decided to invest money into this project and just produce 400 units upfront. Amazing. Based on the fact that they were convinced that it was going to work. And in fact, it seems to be working out well. So yeah, really like huge stroke of luck on my part, and very thankful to them, to trust the project and also my work in the sense that I was supervising. I put in this SMT order, and if that went wrong, that would have been an issue.
Yeah. Well done. That's really exciting. A fantastic project.
Yeah, very exciting, very nerve-wracking. And so for this bigger one that I have here, what I'm planning to do right now is just, I'm having had the experience of this, like, this is not large-scale production at the end of the day. 400 units is not, that's not mass production. But, coming from like, I'm going to make a board for myself, it's a huge step up. Yep. And I'm curious about exploring now something that's even more in between, like I guess you could say like a boutique approach, where at least for now, who knows, for the bigger keyboard, what I'm going to do for the first units, who knows how many, I'm going to be assembling them myself with a little vacuum pump and solder paste here. And I'm going to laser cut the panels myself with machines that I have in the Fab Lab.
Yep.
And it's going to cost more for sure. I can't compete with the kind of pricing that you can get if you raise the numbers. But what I can offer is open source hardware. That's going to be part of it. I can customize the materials based on what you want. As a client, I can do metal. If these I have to outsource, I can't do metal plates on my own at the moment. But I can do different types of wood, different finishes, and acrylic of different colors and things. So it opens up some other opportunities that you wouldn't have if you have to go for a streamlined production process. Yeah. And I'm excited to see how that goes. And yeah, definitely going to be a different pace. I'm also curious to see how it feels to make, 20 PCBs. It's going to be very different kind of workload. And right now, I'm hoping it's going to be something of a relaxing break. Who knows? I might get very annoyed. Yeah.
Fingers crossed for you.
Yeah. I mean, I've done a couple iterations now, and I found some glaring problems in my workflow. Okay. So I was using hot air, just like a hot air station to solder them. And I realized pretty quickly that the amount of time that you spend reflowing each individual component is just not feasible for something like this. Like on a keyboard here, there's 53 keys, and each key has one LED on the one side and then a dial on the other side.
Right.
So that's already 100 components that you basically individually have to, babysit for 5 to 10 seconds. Plus all the oopsies and things that happen in the meantime. So in the Fab Lab, there's an electronics department of the university that has a room adjacent to us that we share. Okay. Where they have electronics workbenches, and there's a hot plate, and they have decided to buy an IR oven.
Nice. Okay.
So I'm hoping that will work for me.
Yeah.
Fingers crossed.
Fingers crossed. Good stuff. Well, I think we are a bit over time. Are you happy to finish there? Anything in particular you want to say?
Sure. No, I think we covered a lot.
No, it's been really great talking.
For the opportunity, and I really enjoyed these casts. I told you before the stream, I think it's a nice format. I'm really enjoying to listen to them and watch them. So
I'm delighted.
Thanks for that.
Thank you for saying that. Yeah, fantastic. All right then. Well, thank you for coming on, and it's been really, really good to talk and see all your projects and things.
Yeah, likewise. Have a nice evening, everybody.
Bye, everybody. Just before we go, I'll say that we're talking with Joey Castillo next week about LCDs, watches, and low power design. Bye all.
Bye-bye.